Okay, so I want to talk about RAG. I've been trying it out since our last meeting, and I've been fascinated with the knowledge I've gained. So I'm using RAG and DeepSeek to query the data source and then give me responses based on my data source. And this is Streamlit, a package for Python. Instead of me using console for querying uh, for user query, I just use Streamlit, a UI that allows me to focus on my code. So this is one of my data source, which is this Excel sheet that has medical symptoms and then the disease. So if I should pick up a symptom like this, let's just pick this particular one and put it here. So it's gonna take a while to respond because I've been trying to figure out why DeepSeek is taking so long. But I'm gonna work on the optimization. For now, I'm just trying to show that I've learned to RAG, and then I've also seen how DeepSeek works. So it takes like, I think a minute or two. After this, I will show you my code to see what I did. See. Okay, while waiting, let's just go to the code. So this is my app. This is where I call the Streamlit using a virtual environment. So this is where I call the Streamlit. I define the title, sidebar. This is my query engine, which is a method coming from the main logic, the embedding models, the RAG itself, and this is the user query. It sets up a spinner, which you see, and then it saves the response as a variable and then it returns the response. So let's see if it came out. Yeah, this has come out. So this is how DeepSeek works. It tells you the thought process, which is in the think section. Starts here and ends. Where did you end? You can see it's like, yeah, ends here. So based on the provided context, the symptoms, persistent hunger, weight loss, and dehydration do not directly correspond to specific disease listed in the given file. But however, if we consider possible underlying conditions, anorexia, nervosa, avoiding restrictive food intake, disorder, dehydration. Now let's pick up everything. Just post it and see if it's gonna bring it up. So let's go back to the code. So what I did is this is my query engine. Yeah, I pass in my part that contains my data source, which is here, and then also pass in an index.json, which is saved for reusability, so that I don't have to load the data over and over again. So once it's loaded, I just keep using this one that is loaded. I was trying to optimize it, and that was why I did it this way. So what it does is that it sets an absolute part here for my data source, and then I initialize my model from Hugging Face embedding using the name all mini LLM. And then what I do is to check if my index has already exists. And if it exists, I just read from my file parts and then pass it directly to my vector DB. If not, I load it from the very beginning and then run it asynchronously here, which is yeah. I load it and call my data source and then using a thread to run it synchronously and then pass um this method here, which returns the loaded data. And then this is run asynchronously using a thread and then converted to a list of documents. And then this list of documents is parsed into this variable. Now, this settings is a global object that this vector store index uses. I define my embedding model. Sorry, the one that is defined here, I pass it into settings on embedding model, which is gotten from LlamaIndex.core. And uh, this is being used by vector store index internally. So I pass my docs into the vector DB and then initialize it, which is now an index. I persist it so that I can reuse it over and over again. And then I print it. Now I also define my LLM, which is using DeepSeek. And I pass the LLM to the settings, which is being used by the vector store index internally. Now I create my query engine, which is on my vector DB. And then it calls the method as query engine and then passes it to query engine. I create my prompt string saying given the following context, answer the query. And then I pass it to my prompt template, which creates a prompt template. And then I pass it to my query engine and update the prompt here and return it as a method. And this is called apps.py. Whenever the user queries is being sent, searches my DB and then gets the prediction. So this is the thought process again. It ends. I keep looking for it. Okay, ends here. So the symptoms we've listed: persistent hunger, weight loss, hydration, visible peristalsis, palpable mass, fuzziness indicates potential complex health issue that requires medical attention. Here's a breakdown. So conclusion: the combination of the symptoms points towards anorexia nervosa alongside dehydration. Now let's check. Oops. Why? I don't know. Let me pick up something else and pick up this and try. I don't know. Doesn't that seem to be accurate? But I've been trying it and it's been accurate. But I'm working with RAG and I'm saying that okay, potentially we can use our own data source, and this is broken down into chunks. Documents is broken down into chunks and then sent to the vector DB, and the vector DB is now sent with a prompt to an LLM, and then it responds based on our query. So you see, answer Sjogren's syndrome. So based on this, I've been able to place my hand on RAG, and I went through the videos with neural networks from three blue, one brown, and to understand the context of neural network. So I'm going to use this for my project. I'm going to use this for my project, which is this proposing proposal for neural network patient match. I'm going to use RAG and LLM to see how I can use to get patient match. So this is what I've been able to come up with since I'm researching. See, my chatter is quite large, learning a lot. First interview with dog. uh, I need to learn on the 16th. Learning rag with dog. A couple of things on the 17th. Three blue, one blue, three blue, one brown. Here, I checked people's articles on rag. Here, experimenting this. I used the Ulama models on my laptop. Yeah, I started neural network and I continue learning neural network. Yeah, openly I launched ChatGPT operator. So this is what I've been doing so far. You for your time with my chit chats.